Speedstack Flex is for designing and documenting rigid flex PCBs. In addition to capabilities for rigid flex, Speedstack Flex has the capabilities of all the other Speedstack editions, Speedstack HDI for high density interconnect and Speedstack for rigid PCBs. There are two versions of Speedstack Flex, Speedstack Flex PCB for impedance controlled PCBs and Speedstack Flex SI, which has capability for both impedance and insertion loss controlled PCBs. Speedstack Flex allows you to document an unlimited number of layers and an unlimited number of cross-sections. You can also add as many transmission line structures for insertion loss or impedance as you need on every individual layer and each area of the cross-section. The next slide is a practical demonstration of Speedstack Flex in action. In this brief overview of Speedstack Flex, I'm going to use an existing 12-layer stack up which has got multiple flex rigid cross sections. Opening the existing file, the first view you see is what we call the master stack. The master stack is a container for all the materials in the stack. If you're sharp-eyed, you might have noticed a couple of gaps here. These aren't air gaps, but these are actually the materials which we'll use in the flexible substacks. So you can see there's a couple of cover lays hidden away here in the master stack. To see every cross section, I'll open the navigator view, and here in the navigator view you can see the master stack with each substack set side by side. Every substack is available for editing, and every substack contains impedance control structures if you like. To generate a printout and a report, it's as simple as going to the File menu, Print, Technical Report, and you'll automatically have a multi-page report of the whole stack up. You can see an overview, you can see the geometrical details of the stack, drill reports. If you've got Speedstack Flex SI, you can see the insertion loss characteristics of the stack. And each of the substacks are documented to here in full detail. Going back to a single page view, I can display each section of the stack in turn. Coming back to the navigator view, it's very easy, for example, to select a substack and copy and paste that stack, and you can paste it at any position, to the left of its existing position, to the right, or across to the far right of all the substacks. So here we've, in a few clicks, added an extra substack to this layer stack up design. If I select one of the copper layers, it's very easy to add an impedance controlled structure. We can apply a 50 ohm microstrip, and there you've got the 50 ohm microstrip documented in the layer stack up. Early on I mentioned that you can see some gaps here which are actually the cover lays which are hidden away because they're not used in this part of the stack up. When you look at the navigator in detail, and if I undock it, float it, make it larger, you can see in more detail where the cover lay is used. Some people like this because it's very clear to see that they've used a cover lay. Others say it doesn't represent the true layout of the substack, and they'd like to see the no-flow pre-preg line up with a cover lay. And that's easy to do if you select into the materials. I'll select the no-flow pre-preg and dock the navigator for a while. Edit, FlexLav, move down, and then re-expand this. Now you can see I've lined up this no-flow prepreg with the cover lay all the way across through each individual substack. Let's do that once more. Go back to here, select this no-flow prepreg, move this one up. Now you can see they're all lined up. Generate another printout, print a technical report. And now you can see that we've lined up the materials in the technical report too. So if you like your technical report to look like the actual build, using the Flex Nav move up and down is a very convenient way of doing that. This is just a graphical representation. If you want to see how the materials apply and are scaled correctly, you can take a look at the proportional view, and the proportional view presses all the materials together and shows you the stack up as it would appear when finished and pressed. And in this case you can see which materials are core materials, which materials are prepregs, where the copper presses into the prepreg, and you can see very visually if you've got an incorrect material because the scale will appear wrong in the proportional stack view. So it's a convenient quick check and a sanity check for when you're generating stack ups to see if the dimensions of the material you're using are correct. If you like the report to look more stylish, you can click it into 3D view and display the report in 3D view, and it's very good for using screenshots and that kind of picture in your documentation. Thanks very much for watching this overview of Speedstack Flex, and I hope you enjoy using it. If you'd like to see Speedstack Flex for yourself, please contact your local Polar office, and the details are shown on the following slide.